Okay, question 1. Given that f of 0 equals -12, find the value of q. Okay, question 1, guys, hopefully straightforward. We just sub in 0, f of 0 equals 0 minus 3, which is -3, into 0 plus 0, because times 0, plus q, and this equals -12. Multiply this out, guys, we get -3. Q equals -12. Q is equal to 4. -12 divided by -3 is 4. Okay, that's question A. Question B. 5 marks. Find the range of values of p for which the cubic equation f of x equals 0 has only one real root. Okay, so guys, a cubic, certainly a positive cubic, well, sorry, both cubics, any cubic, has at least one, because it goes up, then down, then up. So it's always gonna, it goes to negative infinity and then to positive infinity. And the negative ones go down, up, down. So again, positive infinity to negative infinity. So it's always going to cut the x-axis. But where the x-axis is depends, or how many roots it has, depends on where the x-axis is. So if the x-axis is like there, it will have 3 roots. If the x-axis is here, it will have 1 root. And if the x-axis is here, it will only have 1 root. So he's asking, when will it have exactly 1 root? Now, without even drawing it, there's a way to do this, because one of the roots is going to be x equals 3 because of this here. So now if I sub in 3 here, I immediately get 0. So I'm going to have x minus 3, and then when I factorize this, I'll have this and this. So this equals 0, this is equal to 0, or this equals 0. What I need is this quadratic, this bit, to have no roots. And how does a quadratic have no roots? Well, it's when the discriminant, I'm going to write it here, the discriminant is less than 0. So let's write out the quadratic. X squared plus, now it's p minus 2x, p minus 2 brackets x plus q, but that's now 4, equal to 0. If this has no roots, then we have a situation where the cubic only has 1 root. Okay, so discriminant is less than 0. Discriminant is b squared, p minus 2 squared, minus 4ac, 4 times 1 times 4, has to be less than 0. So I have, okay, let's just do it the normal way, guys. I'll expand this out. I have p squared minus 4p plus 2 minus 16 less than 0. P squared minus p squared minus 4p. Sorry, that's a mistake, guys. What am I doing? That's a 4. P squared minus 4p plus 4 minus 16 is minus 12 less than 0. Factorize this. I get p minus 6p plus 2, just make sure you know how to do that, less than 0. I then always sketch this, guys. Sketch this, p at 6 here, p at negative 2. So this is like p equals 6, p equals negative 2. That's where it equals 0, but I'm just going to sketch it here. You can, of course, guys, at this point use your calculator as well, but just to show you how it works, here's the quadratic. Where is this less than 0? Well, it's less than 0 between negative 2 and 6, because that is under the x-axis. So p is greater than negative 2 and less than 6. Okay, that is question 1. Question 2. Okay, let me zoom out a little bit. Okay, we have a graph. Figure 1 shows part of the curve S with this equation. The asymptote to S is parallel, that is parallel to the x-axis equation this. Okay, y-axis equation this. Fine, it's all given. Okay, fine. Crosses the y-axis at 0p. Okay, so this, guys, is p. Okay, first find the value of A. Okay, well, A, guys, because our horizontal asymptote is -2, our A has to equal -2. That is because in these rational functions, the horizontal asymptote is where it's the coefficient of x over the coefficient of x in the numerator over the coefficient of x in the denominator. So it's, sorry, -2. So, because -2 over 1 gives me -2, which I need. Okay, part 2. Well, let's just go B. So B is here. Where this curve crosses the x-axis, ax plus b must equal 0, because a curve crosses the x-axis when y is equal to 0. Hence, if y is 0, the numerator here has to be 0. So ax plus b has to equal 0. We know it crosses when x is 4, and we know a is -2. So this is -2 crosses at 4, so x is 4, plus b equals 0, -8 plus b equals 0, b is equal to 8. So here, b is equal to 8. Next one, C. C, curve crosses the x-axis at the point with coordinates, oh sorry, what are they? This one, C. Here, okay, so the denominator equals 0 at this vertical asymptote. So x plus c has to equal 0 when x is -3. So -3 plus c equals 0. C is equal to 3. This is from everybody. The denominator equals 0. We get a vertical asymptote. So when the denominator is 0, there's a vertical asymptote. Hence, c is equal to 3. And then finally, find p. So p is where it crosses the x-axis, when, sorry, p is where it crosses the y-axis when x is 0. So y is equal to 0 plus b over 0 plus c. And that y is p, and we know now b is 8, and we know c is 3. So p is equal to 8 over 3. Okay, that, guys, is question 2. Question 3. Figure 2 shows a solid right circular cylindrical metal rod. The diameter of the rod is x. Okay, we're given this. The rod is being heated such that the length is increasing at this rate. Okay, so that's the length of the rod. I'm going to call this length, guys, h, just because it's a cylinder. So this is dh, dt is this. Find the rate of increase in centimeters cubed per second of the volume. So we want to get dv dt, and then it's when x equals 3, and 2 significant figures. Okay, lots of important things there. So I want to get dv dt. dv dt, let me write it up here, guys. dv dt is equal to dv, now the other variable I'm dealing with is h, so let's go dv dh times dh dt. You can think of these as cancelling. So that's the kind of setup. Okay, so I have dh dt. I just need to get dv dh. And to get dv dh, obviously first I need volume. It's a cylinder, so it's pi r squared h. So the volume is pi r squared h. Now, I don't want the radius involved here. There's an x there, guys, but I'll deal with that. I'll deal with that after. Let's first just get dv dh. So v is pi r squared h, but I don't want the r, so let's just over here say that, and be careful, guys, that's the diameter. X is the diameter, so r is like x over 2. You want to think of it like that. But what I care more about is how much bigger is the height than the radius. Well, it's 10 times bigger than the diameter, which means it's 20 times bigger than the radius. So h is equal to 20 r. which means R is equal to H over 20, like this. Okay, so that means my volume is equal to pi r squared H over 20 squared times H, pi r squared H. Okay, so this gives me H is equal to, V is then equal to pi over 400, let's write it like this, pi over 400 times H cubed. Okay, now I do dVdH because I'm ready to differentiate it. So dVdH is equal to multiply by the power 3 times pi over 400 times H, subtract 1 from the power, squared. Okay, now I have dVdH. So dVdH is this. I can sub it back into this now, but, well, yeah, let's just do that here, guys. Hang on. I'm going to say, okay, dVdH is then equal to 3 pi over 400 H squared times 0.005. But what is H? Well, I want to find it when x is 3. So when x equals 3, H is equal to 10 times 3, which is 30. Okay, so my, sorry guys, this is a mistake. That was dv dt. That is this. dv dt is this. So that's dv dh. dv dt is dv dh times dh dt, which is 0.005. Okay, so now I can just say dv dt is equal to 3 pi over 400 times h squared, which is 30 squared, times 0.005, and that gives me, hopefully, a correct answer. Okay, this is equal to, 1 second, this is equal to, what is going on? Okay, this is equal to, okay, I need this, I need 3, I need pi. Oh, this has got so big, guys, but whatever. 3 pi over 400 times 30 squared times 0.005 gives me 0.1060. 0.1060 ... Two significant figures, and this is right, guys. Approximately equal to 0.11, and it's centimeters cubed per second. Okay, that is question 3. Question 4. A particle moves along the x-axis at time t seconds. The acceleration is given by this. When t is equal to 0, p is at rest at the origin. So that means when t equals 0, just be careful here, guys. This means t equals 0, v equals 0, because he's at rest. At the origin, s equals 0. So he's at the origin, he's at the beginning, he's at O when t is equal to 0. Okay, find the velocity of p when t is equal to 2. Okay, so this, guys, if you recall, I use SVA, differentiate to go that way, and integrate to go that way. So if I have acceleration, and I do, it's 6t minus 12. To get v, I integrate 6t minus 12 with respect to time. In this case, I get v is equal to 6t squared over 2 minus 12t. Don't forget plus c. Now I'm going to use this t equals 0 when v is equal to 0. So that gives me 0 equals 0 minus 0 plus c. So c is equal to 0. So that means v is equal to 6 over 2 is 3, so it's 3t squared minus 12t. He wants it when t is equal to 2 at 2. V equals 3 times 2 squared minus 12 times 2 equals 12 minus 24 is negative 12. So it's negative 12 velocity, that is meters per second. Okay, part B. At time t, capital T, t is greater than 0, p is instantaneously at rest. Find the value of t. Okay, instantaneously at rest means, guys, that the velocity equals 0. So first thing I'm going to write is velocity equals 0. At rest, that's what that means. He's not moving instantaneously because he's, I don't know what he's doing, but maybe if he bounced on the ground, just for that instant, you are not moving when you bounce. So v is equal to 0, so I'm just going to say 3t squared minus 12t equals 0. Factorize this. 3t into t minus 4 equals 0. This equals 0 or this equals 0, so t equals 0 or t equals 4. We know he's at the velocity 0 when t is equal to 0 from the start, guys, and he says there's another t which is greater than 0, hence capital T is equal to 4. Therefore t equals 4. Okay, part C, find the distance traveled by p in the first 8 seconds of its motion. Okay, this, guys, is slightly tricky because we need to find what this guy is actually doing. Now, the distance traveled, I'm actually going to graph this, guys. So let me try and draw it here. See, I'm going to draw a little graph of what's happening. Okay, now the velocity, we start here, is 0. And we know it's 0 again at 4. This is actually, everyone, this is a quadratic equation, everyone. So it is this that I'm drawing, this 3t squared minus 12t. And I'm going to draw it here. It goes down, it goes up, and it does this up until whatever this 8. This is going to be when t is 8. So this is 4, this is 0, and this is 8. Now to get the distance, I need to find areas. I need to find this area, and I need to find this area, and I need to add them together. Okay, so how do I find the area? Well, I integrate. So it's the integral, let me just write it here, the distance equals the integral from 0 to 4 of 3t squared minus 12t, 3t squared minus 12t dt, plus the integral, now I'm not finished, guys, so just hang on 2 seconds, of 4 to 8 3t squared minus 12t dt. Now the problem is that this integral will be negative, just this first bit, because from 0 to 4 the function's under the graph is under the x-axis, which means this area is under the x-axis, which means the integral will give a negative answer. So what I could do is, if I put negative there, that would work, because it will be negative, and that'll make it positive. Or, which I'm going to do, just put the absolute value there, and then whatever answer you get here, just make it positive and add it to this. Okay, so we do need to show our working, but I'm just going to show you on the calculator first, guys. If you go to calculate, on this calculator, guys, well, on the other calculator, I think there's literally an integral button here. You just press shift and there's one around there somewhere. But in this one, you go to catalog, function analysis, and then integration here. And then we're going to go from, now watch this, I'm going to go from 0 to 8. Now you can only do this on the calculator, guys. Do not try and do this without or in one go here. Here you have to split it up. In this situation, we go from 0 to 8, and I want the absolute value. So I go back to catalog, go down to numeric calc, and then absolute value there. And here, I'm literally going to write in 3x squared minus 12x. Press enter, and that's the answer. The answer is 192. Now guys, you can like just lock that in somewhere like 192 so that you know that's your answer, but you do need to show you're working here, guys. So let's do this. So it's the integral of this. So it's 3t cubed over 3t cubed over 3 minus 12t squared over 2 mod of that, and well, sorry, mod of this because it's going from 0 to 4, then plus similar thing here, 3t cubed over 3. Now that's just t cubed, guys. 3 is cancelled, and that's 6t squared, and that goes from 4 to 8, and then sub this in. The 0 is going to cancel, guys, so that's going to be t cubed. That's 64 minus 6 times 4 is, no, sorry, it's 6 times 4 squared. 4 squared is 16. 6 times 16 is 96. So that's 96 mod. It would be subtract 0 when you sub in the 0, but that's obviously nothing. And then this becomes sub in the 8. 8 cubed is, what's 8 cubed, guys? It's 256. No, that's not right. It's 512, sorry. 500 and, no, is it? Yeah, 512. I should know that. 512 plus 6 times 8 squared, 6 times 64. Okay, guys, who am I kidding? Let's just use a calculator. Okay, it's 8 squared, 64 times 6. 64 times 6 is 384, so that's 384. And then minus sub in the 4, that is 64 plus 4 squared is 16 times 6, same thing, 96. Okay, this, guys, looks, I'm sorry, it's a minus. I was wondering why that looked so wrong. Minus that, and then 64 minus that. Okay. Okay, let me just make sure this is right. So we've minus 32, but it becomes positive, so it's plus 32. So it's 32 plus, what's 512 minus 384? Let's do it. 512 minus 384, 128. So it's 32 plus 128, and then minus, but it's negative, minus 32. Please give me, guys, 192. So it's 128 plus 32, and then plus another 32, and I do get 192. Okay, so bit of working required there, guys, but the calculator has given me the right answer pretty easily. Okay, that is question 4. Question 5. On the grid opposite, draw the graphs of the lines with equations this, this, and this. Okay, fine. Let's first, guys, let's first do that. Okay, part A. So a few different ways to draw these lines. My preferred method is to get an X and a Y, 2 points for each of them. Okay, so I need XY, XY, XY. For this, this, and this. Okay, so for the first one, when X is 0, Y is, because that goes to 0, so Y must be 8. So when X is 0, Y is 8. And I'm going to go when Y is 0, X is 12. Okay, and then we can just put in the points 0, 8 there, and 12, 0 here. So definitely choose 0 if it works, guys. It doesn't always, but definitely does there. Okay, next one, I'll change the color. Here, when X is 0, Y is 0, and then when X is, pick anything you want. Let's go with 6, 0, Y is 0. I'm sorry, this one. When X is 6, Y is 12. So 0, 0, and 6, 12. There you go. That is this line here. And then for this one, different color again, when x is 0, y is, well, we'll have to do negative 12 over 3, which is negative 4. And when y is 0, I'll do, when y is 0, x, a little bit of rearranging, guys, 2x is equal to 12, and x would be 6. Okay, so, and actually, sorry, I just realized 0 minus 4 is no good, is it? Because 0 minus 4 is not on the page. Okay, so let's do a different one. 6, 0 here, and let's go with when x is, I don't know, 2. If x is 2, no, that's not good. When x is 3, y would be negative. Okay, let's pick a bigger one. When x is 9, when x is 9, that would give me 18 minus, let's get rid of that. So when x is 9, that would give me 18 minus 12, which is 6. 3y equals 6, y is equal to 2. Okay, so it's 9 and 2 here. Okay, so then I join these like this. Okay, that's part A. Part B. Show by shading the degree of the region or defined by these inequalities. Okay, so 2x plus 2y is less than 24. So just to recap, guys, this is blue, this is purple, and this is green. Okay, I always pick a point, guys. So it's pick, say, 0, 0. Is that less than or equal to 12? Yep. So we're down this side of the blue line. So it's down here, down that way of the blue line. Pick a point. Okay, so we can't pick 0, 0 here, but let's pick 6, 0. Would 6 be greater? 6 times 2, which is 12. Is that greater or equal to 0? Yep. So it's going to be this side of the purple line. And then the green line, I'll pick 0, 0 again. 0, 0 is 0 greater or equal to, is 0 greater or equal to 0 minus 12? Yes, it is. So it's this side of the green line. Okay. Now we're going to shade this region, and let's call it or, but we're going to shade it. So it's here. Okay. And then he says, done. Then he says, find the greatest value of f, where f is equal to 2x plus 5y. Okay, so to do this, guys, so it says for all the points in or, so in this region, find the greatest value of f, where f is 2x plus 5y. So we just need to pick, we can pick any points in here and find which is the biggest. Now you could say, well, which one will I pick? There's actually an infinite number of points in here, and my answer would be, yeah, fair point. But what you want to do is pick the corners, because the corners are the ones, it's going to be one of the corners that actually gives you this maximum value. Now, which corner is it going to be? Well, look, it's definitely not going to be 0, 0, because that's just going to give me 0. 6, 0, highly unlikely, because that would just give me 12, so it's probably not going to be that one. Could be this one. This, guys, would be like, I think that is 9, 2. So 9, 2 would give me like 18 plus 10, which is 28. Fine. But I have a feeling it's going to be this one. 3, 6. That would give me 6 plus 30. It's definitely going to be this one, because it's 5y, guys. It makes sense that it would be the one with the highest y, sorry, the highest y. So sub in, I'm going to go sub in 3, 6, and then I get 2 times 3 plus 5 times 6, which is 36. Okay, done. That, guys, is question 5. Question 6. Given that root 9 minus x can be expressed in this form. Find the value of p and q. Okay, so basically put this in this form, guys. I don't think this is too bad. This is 2 marks. I'm going to basically take out this 9, guys. So it's like, there's like root 9 times root 1 minus, now if I've divided this by 9, I've divided this by 9. So it's like x over 9 or a 9th x. So this is equal to 3. This is equal to 3 times the square root of 1 minus 1/9 x, like this. Okay, so what's p and what's q? Well, p is equal to 3, this one, and q is equal to -1/9. Okay, easy, part B. Hence, expand this in ascending powers of x up to and including the term x cubed, expressing each coefficient as a fraction in its lowest terms. Okay, so basically, guys, sub this into this. Now, be aware there's a 3 there. Fine, but it's 3 times 1 minus a 9th x to the power of a half. Okay, so we get 1 plus n is a half, and then x, careful here, guys, is negative 1/9 x, or negative x over 9. Okay, plus n, which is a half, times n minus 1. A half minus 1 is negative a half, over 2 factorial, which is 2, times x squared, which is minus x over 9 squared. And then I have to keep going, guys, because he wants to the power of 3. So plus a half times negative a half times negative 3 over 2 all over 3 factorial. So it's the next factorial, guys. So 3 factorial is, well, it's actually 6, but let's leave it like that for now. And then negative x over 9 cubed. Okay, now, obviously, guys, I'm going to put approximately equal to, because I rounded it. Obviously, use your calculator here so you don't mess this up. But, I'm sorry, I should have actually made sure we said this is all times 3. Okay, now, multiply by 3, so 3 times 1 is 3. Then a half times a 9th, that's over 18, so it's 3 over 18. Let's just put the 3 over 18 x. Then 1 minus plus, so this is going to be minus. It's going to be minus 2 times 2 times 2 is 8 underneath the line, and there's 9 times 9 is 81. So this is actually going to be 3 over 8 times 81. All right, I'm going to use my calculator. 8 times 81, 648. Okay, so this is 3 over 648 x squared. And then finally, minus. This is also minus, because there's 1, 2, 3, 4, 5 minuses. This is a 3 from here, a 3 from here, and then underneath the line of 2 times 2 times 2 times 6 times 9 times 9 times 9. Okay, again, calculator. So I have 2 times 2 times 2 times 3 factorial, which is times 6, and then times 9, which is times 81. And that gives me 3888. So 3888 x cubed. And this, hopefully, guys, equals the right answer. So that would be x over 6. That is correct. 3 over 648. Let's just do that quickly, guys. 648 divided by 3 is 216. Yeah, so that's minus 1 over 216 x squared. And then 9 over 3888. 9 divided by 3888 is 1 over 432, which is actually wrong, guys. Oh yeah, sorry. It's not 888, because there was another, oops, there was another 3, so that was wrong, everyone. It was Let me just go back. So it is 2 times 2 times 2 times 2 times 6 times 9 times 9 times 9, which is 34992. 34992. Now I would actually expect, guys, when I divide these, because I multiply by 9, that this is just going to give me 3488. So divide by 9, or sorry, 3888. So yeah, I get 1 over 3888x cubed. Okay, fine. Guys, not simple, but definitely doable. There's a formula, just don't mess up the fractions. Okay, part C. Using the expansion you found in part B with a suitable value of x, find an estimate to 5 decimal places for this. Okay, so guys, what we have is root 9 minus x. This thing here is root 9 minus x. So root 9 minus x. This is part C. That's what I'm going to use. But I'm trying to find, let's just do that. I'm going to find root 31 over 4. Okay, so I'm going to let 9 minus x equal 31 over 4. Okay, why that? Well, because this is the expansion for root 9 minus x, and he wants root 31 over 4. So here we go. Okay, let's rearrange. I'll do it quickly, guys. X is 9 minus 31 over 4. 9 minus 31 over 4 is actually 36 over 4 minus 31 over 4, which is 5 over 4. Okay, then I'm going to sub in to this expansion. Sub into expansion. Okay, now because he wants decimal places, guys, I'm gonna sorry, 31 over 4. I'm just gonna use 1.25. 1.25. Okay, so this is approximately equal to 3 minus 1.25 over 6 minus 1 over 216 times 1.25 squared minus 1 over 3888 times 1.25 cubed. Okay, this should hopefully give me the answer. 3 minus 1.25 over 6 minus 1 over 216 times 1.25 squared minus, and then I'll just do 1.25 cubed over 3888. Okay, and I get 2.7839, and he wants it to 5 decimal places, or 5 decimal places. Okay, so this is equal to 2.78393. 2.78393. Okay, done. Again, guys, not easy by any stretch of the imagination, but definitely manageable for everyone. Question 7. The nth term of a geometric series G is u of n. First term of G is a, common ratio is r. Given that u3 is this, u7 is this, show that r is equal to root 2. Okay, number of ways you can do that, guys. Well, 2 main ways. 1 using the formula, and 2 using, I think my way is actually just quicker. So if u3 is 4 and u7 is 6, u3 times, think about this, if you times this by r, you get u4, by r again, you get u5, then u6, and then u7. So if I just multiply by r to the power of 4 equals u7, I should be able to find r, because u3 is 4, so 4 r to the 4 is equal to 16. So r to the 4 is equal to 16 divided by 4, which is 4. R is equal to the 4th root of 4. The 4th root of 4, guys, is equal to root 2. Okay, you can do that also, everyone, with the formula a or to the n minus 1 and sub in your things in simultaneous equations, but I think mine was a bit faster. Okay, part I, that's part I. So part I, find the value of a. So a times, similar thing guys, a times r gives me u2, and then times r squared gives me u3. Now I have r, it's r root 2, so this squared equals u3, which is 4. Root 2 squared is 2, so 2a equals 4, and a is equal to 2. It's a find question, guys, but show you're working properly. Okay, part B, I'll do over here. Find the least value of n for which u of n is greater than 500. Okay, so now I'm going to use my formula. Un equals a or to the n minus 1. Okay, a is 2, and let's do it over here. 2 or root 2 to the power of n minus 1 has to be greater than 500. Okay, this means root 2 to the power of n minus 1 must be greater than 250. Okay, number of ways you could do this, guys. I think we can just do consider 200, or I'm going to do log, guys. I'm going to do log 250 base root 2. So this will tell me that what do I need to raise root 2 to get 250. Okay, so I'll do log. Let me go with log, guys. Where are you here? Okay, this is log. There, I want root 2, and I want 250, and this is equal to 15.93. 15.93. That means, everyone, that n must be greater than, n minus 1 must be greater than 15.93, which means n minus 1, or n must be greater than 16.93, but n is it's a whole number because we're talking about the series here, so I'm just going to say therefore n equals 17. It's the next whole number greater than 16.93. Okay, that's part B. Part C, find S20, giving your answer in this form. Okay, formula, guys, for sum of n terms. I'm just going to write it here. Is it in the formula sheet? I think so, everyone, but not 100% sure at this exact moment, but I think it is, but let's write it out here anyway. It is a times r to the n minus 1 over r minus 1. And I know a is 2, I know r is root 2, and I know n is 20. So I can just sub these into my formula. So S20 is equal to a, 2, r is root 2, so it's root 2 to the n, root 2 to the n, minus 1 over the n, I know, n is 20, so it's root 2 to the 20, root 2 to the 20 minus 1 over, or root 2 minus 1. Okay, this is equal to, I'm just going to write it over here so I don't run out of space, 2 times, okay, root 2 to the power of 20, guys, is, I can actually do that in my head, it is 1024. How do I know that? Because root 2 to the 20 is the same as 2 to the power of 10, and that's one of those ones you should know, guys. 2 to the power of 10 is 1024, but obviously you have a calculator, so you could do it here if you wanted. Root 2 to the power of 1024. Okay, minus 1 over root 2 minus 1. Okay, now this is obviously not in this form, so let's just keep going. By the way, this is 1023, so this is going to be 2000, and let me get this right. This is 1023 times 2, so it's 2046. So it's 2046 over root 2 minus 1. Now, to get it in this form, I need to multiply by, hopefully you remember this, guys, root 2 plus 1 over root 2 plus 1, the conjugate of the denominator to get rid of the root underneath the line. Okay, that will give me, let's go down here, 2046 times root 2, and then 2046 times 1. Now actually, I'll keep, because he wants it like this, I'm going to keep the top as it is in brackets. So it's this times root 2 plus 1 over, and this is actually going to be very nice, guys, root 2 times root 2 is 2, plus root 2 minus root 2 cancel, and then minus 1. So you actually get 2046 times, I'll swap these two just so it looks like this, 1 plus root 2 over 1, which I don't need to write, and that's the form he's asked for. Okay, that, guys, is question 7. Question 8. Figure 3 shows a right prism. Cross-section of the prism is the prism of a triangle. Sorry, cross-section is a triangle. Blah, blah, blah. The point N lies on BC such that Fn is perpendicular to BC. Okay, let's find this perpendicular. Show that Bn is equal to 5. Okay, that, guys, I hope is easy. I mean, I hope you think it's easy. Because Bn is, well, in a right angle triangle, this is just SOHCAHTOA. That's 10 here. So I'm going to say the cos of 60 degrees, cos of 60 is equal to Bn, that's our thing we're looking for, Bn over 10. So Bn equals 10 cos 60. Cos 60, guys, is a half. You can use your calculator if you want. 10 times a half equals 5. Okay, so guys, I deliberately put in the half there just because it's to show that question. You want to show all your steps. Okay, part B. Find in centimeters to 3 significant figures the length of En. Okay, so, right, this is going to be more difficult for sure. E times N. So that's this here. Now, there's En. Let's consider this triangle here. EFN. So it's all about, guys, considering different triangles. Okay, so we know that this is 10. We now know that this is 5. Okay, let's put in these numbers as we find them. This is 5. I know this is 12. I can find Fn using Pythagoras. So let's write this here. Fn squared plus 5 squared equals 10 squared. Fn squared equals, that's 100 minus 25, which is 75. So Fn is equal to root 75. Okay, so now we have Fn root 75, and he wants to find En. Again, I can use Pythagoras' theorem. En squared equals 12 squared plus, because this is a right angle, root 75 squared, which is going to be En is then going to be the square root of 144 plus 75. Let's do that here. 144 plus 75, 219. Now he wants it to 3 significant figures. So it's root 19, sorry, root 219. Okay, let's write it as root 219, which is approximately equal to 14.8. 14.8. I hope is right, guys. 14.8. Okay, part C. Find in degrees to one decimal place the size of the angle between the planes ABCD and the planes AXYD. Sorry, where the point BF is X. Okay, let's just write this down here, guys. BF, the midpoint of BF is X, so X is like somewhere here. And Y is the midpoint of FC, let's say here. And then he wants the size of the angle between the planes ABCD, that's the bottom, and the plane AXYD. So that's AXYD, like this. Okay, now to get the angle between the two planes, guys, so that's going to be this plane here. So it's this plane and the bottom plane. So just be careful. The angle that he wants, guys, is, so when you're getting the angle between two planes, what's important is that the two lines, so you need to get an angle, you need the angle between two lines. So the two lines that you choose have to be perpendicular to both planes. So, sorry, let me say that again. The two lines that you choose have to both be perpendicular to the line of intersection of the planes. So it has to be, I need a line on ABDC that is perpendicular to this line. So I'm going to go with this one. And I need a line on the green plane that is perpendicular to the blue line. Now this is perpendicular to it, guys, if you consider this is all in 3D. Okay, so that line is perpendicular to the blue line, and this other purple line is perpendicular to the blue line. And we're trying to find, and I can even put a line down there, guys, here, and this is a right angle. So we're actually trying to find this angle here. Let's call it theta. Now, if that's theta, I know this is 12 here. And this height, guys, is because, okay, so because these are the midpoints of these, let's call these hypotenuse, we can say that this here, this pointer, sorry, this is just halfway up this line here, this line Fn. So if Fn is root 75, this line here is root 75 over 2. So now I can say tan of theta is root 75 over 2 over 12, which is actually root 75 over 24. So theta is the inverse tan of root 75 over 24. Let's do that. Inverse tan root 75 over 24, close brackets, 19.8, guys, at one decimal place, 19.8. Okay, part D. Okay, 6 marks, guys. This is going to be hard. Find in degrees to one decimal place the size of the angle AYE. So AYE. Okay, I'm going to, guys, get rid of some of this stuff. So let's get rid of this. Let's get rid of this. AYE. Okay, let's get rid of that. Okay, I'll go from A to Y to E and down here. Okay, this is not a right angle triangle, guys. We're trying to find an angle here. Let's call it alpha. So my immediate thought is cosine rule. So cosine rule, we have one length here, 10. I need the other two lengths. I need AY and I need YE. Okay, how am I going to get these? So, okay, let's have a think. What we're going to need to do, guys, is, okay, let's get AY. Let's get AY first. Okay, so I have A to Y here. I need a right angle triangle, guys. So I'm going to actually bring this down here like this. Now, because, guys, that is the midpoint. This is a special rule with midpoints of hypotenuse. It's also the midpoint of this here. So that's the midpoint of NC. That is because if you look at it here, you can end up getting the exact same triangle there, like this. Okay, now note, guys, so that's a right angle, and that's a right angle. Note that's root 75, and that's that big length here. Okay, so this length I can write as, if this was 5, this was 3, so this length here is 1.5. So that is 1.5. So what I want to do here, guys, and I'm low on colors, I'm going to go with, okay, we want this triangle here to get the length AY, because I can get this length here and I can get this length there. Okay, so what I'm going to do, guys, is, well, sorry, this length is root 75 over 2. Okay, so that's useful. This length here is root 75 over 2. Okay, well, hang on, I have it here. This, sorry, well, that was root 75 over 2, but this is the same one. So this is also root 75 over 2. Okay, this length here, let's call this, running out of letters, guys, let's call this point here, let's call it P. Okay, so I can get AP using Pythagoras. AP squared equals, so there's this 12 squared, and there's this is 5 plus 1.5 here, that gives me 6.5, so that's 6.5 squared. So I have 12 squared plus 6.5 squared, so AP is the square root. Let's do this, guys. This question is crazy because I've barely started and I've already done quite a lot of work. Okay, so this is root 745 over 2. Root 745 over 2. So that's this guy here. Root 7. What's wrong with that? Root 7, 4. Can't write it there, guys. Whatever. It's there. AP. Root 745 over 2. Okay. So now that I have that, I can get a y because I can use this. Okay, so a y squared. Now, except guys, this is a bit confusing. A y squared, I'm using this triangle here. A y p. Let me just write triangle A y p here. So a y squared equals a p squared, which is this guy. So it's root 745 over 2 squared, plus this guy, which is root 75 over 2 squared. Root 75 over 2 squared. So AY is equal to, okay, it's that. So it is the square root of, okay, I'll need I need a bracket here, root 745 over 2 squared plus brackets root 75 over 2 squared. Okay, this gives me root 205. So AY is root 205. So now I have AY. Let's just highlight this, guys. I have AY and I have AF. I need EY. Okay, so to find EY, I am going to I'm going to do this. I'm going to do E to F to Y, and then back here. Okay, and that, believe it or not, is a right angle triangle, just because these planes are kind of at right angles here. Okay, so that's a right angle. So I need I need Fy. Now Fy is half of Fc, so first I need Fc. So Fc squared is equal to this root 75 squared. So sorry, that, guys, this full one is root 75, so it's root 75 squared plus 3 squared. So that means Fc is the square root. Root 75 squared is 75 plus 9, 84. So Fc is root 84, which means Fy is root 84 over 2. Okay, so Fy here is root 84 over 2. Okay, and because it's a right angle, I can get EY. So EY squared, sorry guys, EY squared equals root 84 over 2 squared plus 12 squared. EY squared is therefore the square root, sorry, get me out of this, the square root of 12 squared plus root 84 over 2 squared, and that's root 165. So EY squared, well, sorry, EY is the square root of 165. Okay, so I have EY. Okay, now, thankfully, guys, this question is brutal. I can just use cosine rule, because I want alpha. I have this length. This length is root 205, and this length is root 165. Don't know why that's happening, guys. Okay, so I can do cosine. Let's do it here. Cosine alpha. I'm gonna assume, guys, you're comfortable with the cosine rule. If you've made it this far, it's gonna be this squared plus this squared minus this squared, which is root 205 squared is 205 plus root 165 squared is 165 minus 10 squared is 100, all over 2 times root 205, that's a 2, times root 165, and that, hopefully, please, will be the right answer, because I don't want to do this question again, guys. Cos -1 of 205 plus 165 minus 100 over 2 times root 205 times root 165. Well, close brackets here, and I get 42.8, thankfully, guys, that is correct. 42.8 to 1 decimal place. Okay, guys, that final question there was like crazy hard. That is question 8. Okay. The finite region, or enclosed by the y-axis, this line and this curve is defined for points with x is greater than 0. The region R is rotated 360 degrees about the y-axis. Okay, let me write that, guys, about the y-axis. Okay. Use algebraic integration to find the volume of the solid of revolution. Give your answer in terms of pi. Okay, first and foremost, guys, you want to definitely graph this to see what's actually happening. Okay, so I'm going to graph it here like this. Okay, now we have y equals x squared minus 2. That is a quadratic that goes through the y-axis at -2. It looks something like this. And this guy, this straight line, I can rearrange it to be y equals -2x plus 13. So it's going to go through 13. Let's just pretend that's 13, and it's going to have a -2 gradient. Okay, it's going to do something like that. Okay, now in this graph, this is here, this is -2, because from the quadratic, when x is 0, y is -2. And this is 13, because from the straight line, when x is 0, y is 13. The region we're talking about is the region enclosed by the y-axis, the straight line, and the curve. The region is, well, it's this region here. It's this whole region here. Okay, now I need to split it up, guys. I have to split it up into there to here. I'm going to do it from here to here, that intersection point, and then from here to here. So let's actually shade this bit in red. Okay, so now I'm going to spin this around the y-axis, and then I'm going to spin the line around the y-axis, which is actually going to give me a cone. Okay, now what I need is this point here. How do I find it? Well, I can equate these two and find y. Okay, so let's find x first and then find y. So I'll equate, I'll do x squared minus 2 equals -2x plus 13, and then x squared plus 2x minus 15 equals 0. Factorize this. I'll do this bit quickly, guys, because obviously this is the least of our worries in this question. This is x plus 5 times x minus 3 equals 0, x equals -5, and x equals 3. So clearly it's the 3, the -5 is going to be where this purple line meets the green parabola. We care about the 3. So for x equals 3, y equals minus 2 times 3 plus 13, -6 plus 13 is 7. Okay, so this value here is 7. Okay, now our formula, guys, for volume of revolution about the y-axis, this formula is here. V is equal to pi times the integral from a to b, that'll be these integrals here, of x squared dy. Okay, so for each of these I need x. I'm going to do the parabola from -2 to 7 and the straight line from 7 to 13. Okay, so I have y equals, let's do this here, y equals x squared minus 2. Rearrange for x here, I get x squared equals y plus 2. And, well, actually, I can just sub that straight in there, so that's fine. And then for the straight line, I can get 2x. Let's do this with a different color. Okay, I can say 2x equals 2x equals 13 minus y, and then x equals 13 minus y over 2. Okay, I'm going to split it up, guys, into volume 1 and volume 2. Let's go volume 1 equals, this is the red one here. I'll call that one the orange one. Okay, so volume 1 is equal to pi times the integral from -2 to 7. So it's these negative 2 to 7. It's these y limits from where I'm going to get the volume. And then it's x squared. X squared here is y plus 2. So it's y plus 2. And it's dy. So I'm just going to integrate this. This is going to be pi times, integrate this is y squared over 2. Integrate this is plus 2y. Sub in my limits. So it's 7 to -2. 7 to -2. That's equal to pi times big bracket. Sub in my 7. I get 49 over 2 plus 14 minus, sub in my -2. I get 4 over 2 minus 4. Close all this. This is equal to pi times, obviously just use your calculator now, guys, but this is 49 over 2 plus 28 over 2 is 77 over 2. So it's 77 over 2, and this is actually 2 minus 4, which is -2, and is minus 2, so that's actually plus 2. 77 over 2 plus 4 over 2 is 81 over 2. So that's 81 over 2 pi. Obviously, guys, feel free to use your calculator. Okay, that's volume 1. Volume 2 is equal to pi times, so that's going to be this orange one here, guys. Okay, let's just make that orange. So it's pi times the integral from 7 to 13 of this squared. So it's actually 13 minus y. 13 minus y over 2 squared. Now, guys, normally I would actually suggest using the volume of a cone formula. So you can do that here with the height is 6, because it goes from 7 to 13, and the radius is actually this x coordinate, which is 3. So you could find the volume using the volume of a cone formula, which is a third pi r squared h. That's much easier, but he does say use algebraic integration, so I guess I'm going to do that. I'm sure you get full marks if you use the cone, guys, but let's just do that for now. Okay, dy. This, guys, if you're okay with this, I'm going to make this 13 minus y squared over 2 squared, which is 4, and I'm going to take out the 4. So it's pi over 4 dy like this. Okay, so I get pi over 4. Now I'm going to integrate this. Okay, maybe you'd prefer me to multiply it out first. Let's multiply it out. You can do it, but yeah, let's multiply. We get 13 squared, 169, minus, careful here, guys, it's 26y, and then plus y squared. Make sure you know how to do that. All dy, technically in a bracket. Okay, pi over 4. This is all from 7 to 13. 7 to 13. And now we integrate. So it's 169y minus 26y squared over 2 plus y cubed over 3. Okay, I'm going to, guys, give myself more space. And this is from 7 to 13. Okay, now we go pi over 4, square brackets, sub in my 13. So it's 169 times 13 minus 26 13 squared over 2 plus 13 cubed over 3 minus, and then I need 169 times 7 minus, okay, I I need loads more space here, guys. 169 times 7 minus 26 times 7 squared over 2 plus 7 cubed over 3. Close this and close this. Okay, this one, guys, I'm sorry, I'm using my calculator. This is too much. Okay, let's go. We'll do pi over 4. I hope this is going to be right. Pi over 4. So pi over 4, brackets again, 169 times 13 minus 26 over 2 is 13, guys. So that's actually 13 cubed. And then plus 13 cubed over 3, close brackets, minus, open brackets, 169 times 7 minus 26 times 7 squared over 2 plus 7 cubed over 3, close bracket, close the other bracket, 18 pi. Okay, that seems very nice, so hopefully that's right. That's 18 pi. The total volume then, okay, so that's this V1 and V2. So my total volume equals 81 over 2 pi plus this, which is 36 over 2 pi. Add them together, that gives me 117 over 2 pi, which is correct, thankfully, guys. Okay, obviously super hard question, 9 marks and 1 part. So yeah, hard question, guys. There you go. That is question 9. Use the formula for cos a plus b to show that cos 2a is equal to this. Okay, so guys, we are given the formula for cos a plus b. Cos a plus b is equal to cos a cos b minus sine a sine b. Okay, that's given in the formula sheet. Imagine if this was cos a plus a. So now we'll just make b equal to a. So this is cos a minus sine a sine a. This becomes cos squared a, because we're just squaring them, and this becomes sine squared a. Now he wants it as, well, he wants it to look like that, so I need to get rid of a sine squared, so it's cos squared a minus 1 minus sine squared a, and that equals, well, it's, sorry, 1 minus cos squared, what am I doing? So sine squared is 1 minus cos squared a. That's from the Pythagorean identity. And then that equals cos squared a minus 1 plus cos squared a, which equals 2 cos squared a minus 1 q e d. Okay, guys, I only meant to write the first line in pink there, if you're wondering why I'm writing everything in pink. Okay, that is part A. Okay, part B. Show that cos 4a is equal to this. Okay, so we know cos 2a is this. So cos 4a, where we double, we're essentially doubling a. So I need to then double a here. So it's 2 cos squared 2a minus 1. So we just doubled a, so this into 4a, so this becomes 2a. That's fine. But he wants it in this form, which is nothing like my form. So I am going to, okay, so I'm going to split up this, guys. So cos 2a, we know, okay, we know, this is actually kind of tricky. We know, guys, that cos 2a is this, and this is cos 2a squared. So I'm going to write this squared because he doesn't want any double angle in his identity thing here. So let's change this into, so there's still the 2, and I'm going to change this cos squared 2a into this 2 cos squared a minus 1. So that's cos 2a, but, and this is the notation is kind of tricky here, guys. It's cos squared means this squared. So like cos 2a squared is this. So it's this squared, like that. Okay, so this is squared minus 1. And then this becomes, okay, well, it's 2 cos squared a minus 1 times 2 cos squared a minus 1, which equals, and then minus 1 at the end, and this equals 2 times, okay, this times this is 4 cos to the 4a, which I want. Then this times this and this times this will give me minus 4 cos squared a, and then this times this will give me the plus 1, and then there's a minus 1 here, and then if I multiply all this out, I'm going to get 8 cos to the 4a minus 8 cos squared a, and then 2 times 2 is 2 times 1 is 2, and 2 minus 1 is 1, so it's plus 1, which is what he wanted. QED. Part C. Solve the equation this. Okay, so right, this is obviously going to be tricky, guys. We're going to have this times this equals this. Okay, so firstly, this pi over 4 plus, sorry, theta over 4 plus pi over 24, which is here and here. Let's give that another name. Let's use x. So we're going to start by letting x equal theta over 4 plus pi over 24. Okay, this is just till we get our head around what's actually being asked. So it's cos squared x times cos squared x minus 1 equals negative 1 over 16. Now usually, guys, it'll be something to do with parts A and B that we've discovered, but for now let's try and deal with this over here. Okay, multiply it out. I'm going to get cos to the 4x, so this is going to be something to do with this, guys, I'm sure, but so it's cos to the 4x minus cos squared x equals minus 1 over 16. Okay, now we know, guys, that from this cos 4a equals this. Okay, so now the reason I'm doing this, guys, is because I'm just using the assumption that the reason he made me do all this work for part B is to do with this. So we know cos 4a is equal to this. So cos 4a minus 1 equals 8 cos to the 4a minus 8 cos squared a. Okay, so I've just subtracted the 1 to the left. And then there's no 8 here, so let's divide by 8. So cos to the 4a minus 1 over 8 equals cos to the 4a minus cos squared a. Okay, now this here is gonna nicely fit over here. So I'm gonna call this cos 4x minus 1 over 8 equals, so that's this, but instead of my cos to the 4x minus cos squared x, I'm putting that, guys, just so we're clear. That equals minus 1 over 16. Okay, now I think I can go from here. Okay, multiply across by 8, definitely. So cos 4x minus 1 equals 8 times this, 8 over 16 is negative 1 over 2. And then add the 1, so cos 4x is equal to, add 1 over 2. So if cos 4x is equal to 1 over 2, what does 4x equal now? I should actually, guys, note that theta is going between 0 and 2 pi. So let's go here. Theta is between, let's just write it here. I think it's less than or equal to theta. Sorry, it's less than 2 pi, like that. Okay, so if this is theta and this is 4x, okay, so now I'm dealing with, I need to change this back into this. Now, let me just deal with this for 1 second, guys. If theta is between 0 and 2 pi, what must x be between? Well, okay, let me just go over here to the side. So if theta is between 0 and 2 pi, okay, 0 is between, theta is between 0 and 2 pi, which means theta over 4 is between 0, dividing this by 4, and divide this by 4, which is going to be pi over 2. And then I'm going to add pi over 24. So theta over 4 plus pi over 24 is between, add pi over 24 to 0, pi over 24, and add pi over 24 to this, well, it's pi over 2 plus pi over 24. Now that's x. So then 4x, if I multiply this by 4, let's just write it as 4x. 4x has to be between pi over 6, because 4 times this, 4 over 24 for pi over 6, and less than this times 4 is 2 pi, and then 2 pi plus this times 4, which is pi over 6. Okay, so this is my range for 4x. Down here, I'm going to now solve this. Okay, so if 4x is equal to a half, cos of 4x is equal to a half, 4x is equal to, now I personally like it, guys, the cast diagram, which I'm going to go over here and draw this, CAST. And we're like, okay, which quadrants is this in? Well, it's in this quadrant, it is in, and this quadrant, because it's positive. And what's the acute angle? Well, the acute angle is inverse cos of 1 over 2, which is actually pi over 3 that we need to know, guys. So this is pi over 3 here. So that's pi over 3, and that's pi over 3. Now, just to, in case you're feeling a bit stuck here, guys, this question is really brutal. Okay, so we have 4x is equal to cos 4x is equal to a half. So 4x must equal pi over 3, or, and then I kind of go around this circle, so pi over 3, or this guy here, which is 2 pi minus pi over 3, which is actually going to be, it is going to be, 6 pi over 3 minus pi over 3, 5 pi over 3. So this is 5 pi over 3. Okay, then I divide by 4, so x is equal to, so sorry, am I done? Yeah, because it has to be between pi over 6 and 2 pi plus pi over 6. So if I went to another one, I would have gone too far, because I would have passed 2 pi plus pi over 6. So these are the only two solutions. So 4x is equal to this, which means x is equal to pi over 12, or 5 pi over 12. If this is my x, I now need to find theta. So theta over 4, because x is theta over 4 plus pi over 24. So theta over 4 plus pi over 24 equals pi over 12. Or theta over 4 plus pi over 24 equals 5 pi over 12. Now solve this however you want, guys. Why don't we make everything over 24? So that's going to be 6 theta over 24 plus 1 pi over 24 equals 2 pi over 24. And then I'm going to subtract 1 here. So 6 theta over 24 equals 2 pi minus 1 pi, which is pi over 24. These 24s cancel, and I'm left with theta equals pi over 6. That is one solution. Next solution, similar thing, guys. This is 6 theta over 24 plus 1 pi over 24 equals, multiplied by 2, 10 pi over 24. You can actually get rid of all the 24s if you want. 6 theta equals 10 pi minus 1 pi, which is 9 pi, and theta is therefore 9 pi over 6, which is 3 pi over 2. Okay, really, really difficult question, guys. So just so you know, that is part C. I'm going to stop there and do part D in the next video. Okay, part D says, using calculus, find the exact value of this, where f of a is equal to this thing here. Okay, so obviously, guys, this f of a here looks very like this, and I don't want to have to integrate a cos to the power of 4 and a cos squared. I would much rather integrate that. So let's do something. I'm going to say this thing, well, we know 8 cos to the 4a minus 8 cos squared a plus 1 equals, this is d, guys, we know this is equal to cos 4a. We know this from the start. Okay, now I want to turn this into this. How do I do it? Well, I'm just going to divide by 2. So divide by 2, I get 4 cos to the 4a minus 4 cos squared a plus a half, I have to divide this by 2, equals a half cos 4a. I divided everything by a half. Now I'm nearly there. That's nearly f of a, but I need to get 1 here, not a half, so I'm going to have to add a half. So then 4 cos to the 4a minus 4 cos squared a plus 1 must equal a half cos 4a plus a half, because we've added a half to both sides. Okay, so this is now f of a. So I'm going to say this equals f of a. So now to integrate this to the integral of f of a from pi over 6 to pi over 2 is, instead of f of a, I'm going to put that. I'm going to put a half cos 4a plus a half. And this is dA, like this. Okay, so now I have to integrate both of these. This is a much, much easier integral than trying to integrate that. Okay, so this equals, square brackets. The integral of cos 4a is, so I'll put the half here, put the half. Integral of cos 4a is sine 4a, but because the integral of cos is sine, but because of this 4, I need to divide by 4, so it's sine 4a over 4, and there's a half here, and the integral of a half is just a half a. Close this, and we go from pi over 2 to pi over 6. Okay, then I sub this in here. Let's just do it here, guys. So this equals sub in. So this is now going to be sine 4a over 8. Okay, so this is going to be sine 4 times pi over 2. So it's 4 times pi over 2. Just be careful, guys. 4 times pi over 2, which is actually 2 pi. So if you're okay, guys, I'll just put 2 pi there. 4 times pi over 2 is 2 pi over 8 plus a half times pi over 2 is pi over 4. And then I need to subtract. Now I'm going to sub in pi over 6. So it's a half. Oh, sorry, I'll do that over 8 again. So it's sine 4 pi over 6. So this is going to be, I'm going to sub in this. So it's going to be sine of 4 pi over 6. Sine 4 pi over 6 all over 8 plus a half times pi over 6 is pi over 12. So this is pi over 12. Okay, so this becomes sine of 2 pi, guys, hope you know, is 0. Sine of any multiple of pi is 0, so that's 0 plus pi over 4. So that's just going to be pi over 4 minus sine of 4 pi over 6. Let me just do that over here. Sine of, that's 2 pi over 3. So sine of 2 pi over 3 is equal to sine of pi over 3. And that's one of the ones you need to know. It's root 3 over 2. Okay, so that's root 3 over 2. Root 3 over 2 over 8 is root 3 over 16. And then it is minus, oh sorry, it's plus pi over 12. Okay, and then we have pi over 4 minus pi over 12. That's 3 pi over 4. That's like, 3 pi over 12 minus 1 pi over 12 is 2 pi over 12, which is pi over 6. So that's pi over 6, and then minus root 3 over 16. Okay, easier than part C in my opinion, guys, but still difficult. Okay, that is question 10. Okay, question 11a. So we're given this quadratic equation. It says roots alpha and beta. It says given that 2 alpha beta equals 3 and, well, all of this equals this, write down the value of q. Okay, so we'll start, guys, with that we know the sum of the roots, alpha plus beta, must equal, that's like a 1. It's like negative b over a if you want to think of it like that. This is a form you need to know. So it's negative minus p, or whatever you want to call that, which is positive p over 1. So alpha plus beta equals 1, and alpha beta is equal to c over a, if you like, or q in this case, because it's q over 1. So alpha beta equals q. He tells us 2 alpha beta is 3. So 2 alpha beta is 3. So alpha beta is 3 over 2, which means q is 3 over 2. Okay, so that's part I. Part II, he says find an expression in terms of k for p. So p is alpha plus beta. Okay, now I'm going to, generally the technique here, guys, is just you square alpha plus beta, because that'll give me my alpha, that'll give me my alpha squared plus 2 alpha beta plus beta squared. So this is, if you like, p squared. So p squared equals alpha squared plus beta squared is, well, if this is equal to, let me just show you this here, guys. If 4 alpha squared plus beta squared equals this, then alpha squared plus beta squared equals, well, all of this over 4. So it's going to be this over 4. So k squared minus 6k minus 3 over 4 plus 2 alpha beta. Now he's given us 2 alpha beta. It's 3. So it's plus 3. Now, if you don't mind, guys, I'm just going to do plus 12 over 4. That is 3. Okay, this gives me k squared minus 6k plus 9 over 4. That's p squared. So p is the square root of this. Now, guys, it's worth noting that that is, I'll just write p squared here first. So p squared is equal to this. If I factorize this, I get k minus 3 times k minus 3. That is the factors of this quadratic, which is actually k minus 3 squared over 4. So p, very nicely, is going to be the square root of this, which is k minus 3, over the square root of 4, which is 2. So p is equal to k minus 3 over 2. Okay, part B, I'll do over here. Given also that 7 alpha beta equals 3 alpha plus beta, find the value of k. Okay, so now we have p and q. Okay, so this, we have alpha plus beta is equal to p, which is equal to k minus 3 over 2. And we have alpha beta equals 3 over 2. So I'm just going to sub these in here. So I'm going to say 7 times alpha beta, 3 over 2, equals 3 times this, k minus 3 over 2. Okay, that is, well, if you're okay, guys, I'll just delete these two 2's, multiply both sides by 2 and gets rid of that. That makes 21 equals 3k minus 9. 3k equals 30, and k equals 10. Okay, that is part B. Part C, hence form an equation with integer coefficients which has roots of this. Okay, I'm going to just go down here, guys. Okay, so we have, let me do it here. Okay, part C. So these are the roots. I'm now going to add, I'm going to get the sum of these roots and the product of these roots. Okay, so let's do that first. Alpha over alpha plus beta plus beta over alpha plus beta. This is the sum of the roots, is equal to alpha plus beta over, okay, well, this is actually easy, guys. It's alpha plus beta over alpha plus beta, because we just add the top and common denominator, which is equal to 1. So that's the sum of the roots. And then the product of the roots, alpha over alpha plus beta, times beta over alpha plus beta. That is equal to alpha beta over alpha plus beta squared. Okay, now we have alpha beta from here, guys. It's 3 over 2. And I have alpha plus beta, so that's 3 over 2 over, I have alpha plus beta now. I'm just going to write it here, guys. Therefore, alpha plus beta equals 10 minus 3 over 2, which is 7 over 2. So this is over 7. This is now over 7 over 2 squared. Okay, that is equal to, okay, it's 3 over 2 over 49 over 4. Keep, change, flip. 3 over 2 times 4 over 49. And that equals, this goes once, this goes twice. This equals 6 over, that is equal to 6 over 49. Okay, fine. Now, over here, my sum, let's say consider ax squared plus bx plus c equals 0. So we have our, and I'm going to let a equal 1 just for now, and I get x squared plus bx plus c equals 0. Now the sum of the roots is equal to minus b over 1, which is minus b. Now we know the sum is 1, so minus b equals 1, so b is equal to negative 1. The product, we know, is equal to, the product is equal to c over 1, so c is equal to 6 over 49. Okay, so now I have a, b, and c. Oh, sorry, well, I do have a, it's 1. I'm just going to sub in here. My quadratic is therefore x squared, minus bx, so minus 1x, or minus x, plus c, which is plus 6 over 49, and this equals 0. Now, let's go back to the question. He said, form an equation with integer coefficients. Guys, I've seen this many times. Students lose a mark here. This is a quadratic with roots, with these roots, for sure. It is a quadratic with a root, that and that. However, he wants integer coefficients. So what do? Simply multiply across by 49. I get 49 x squared minus 49x plus 6 equals 0. And that, guys, is it complete. And so is the paper.